Hi friends, for allocating memory dynamically in C, we have three functions: malloc, calloc, and realloc. And for deallocating the memory which is allotted by any one of the above functions, we have another function called free. First of all, we can discuss about malloc, which is memory allocation. The syntax of malloc is word star malloc and size in bytes which we want to allocate. Here word star is the return type of malloc which returns the starting address of the allocated memory. And when we look about the argument, it is size in bytes. What does size underscore t mean? It means that size underscore t acts as like a unsigned value. If the size is negative, it's an error, right? For that, it acts like an unsigned, which forcefully converts the negative value to positive value. Even though the negative value is supplied, it raises an error. If you see here, this is full memory which we have, and this red color means this memory is not free for us to allocate for our program. This is being used by another program. So if we want to allocate memory, we must allocate memory which is free, means which is having this green color. So if you write a statement like this, void star t equal to malloc of 4 bytes. This is 4 bytes. Now the system goes and checks in memory, is there 4 bytes of memory is free for allocating here? Yeah, 1, 2, 3 and 4. We have 4 bytes free and we can allocate for this, and then it will allocate 4 bytes of memory for a program and returns the starting address of these 4 bytes here. Now P contains the starting address of these 4 bytes. So if we print P, then that prints 1003, because this is the starting address of the 4 bytes which we have allocated. And now if we want to allocate memory for an integer array of size 4, and if int size is 2, then void star p equal to malloc. So each integer size is 2 and number of integers we want is 4 into 2. We need 8 bytes to have 4 integers. And now again the system searches, is there availability of 8 bytes free for in memory for allocating here. Here 1, 2, 3, 4, 5, 6, 7, 8. Each integer size is 2 byte and we have 8 bytes free here, and then these 8 bytes are reserved for this program and allocated here. See, these 3, 4, 5, 6, 7, 8, and the starting address of this 8 bytes for 4 integers is returned to P. Now if we print P contains 1003. And coming to the actual practice of allocating memory, the integer size may be 2 or 4 or something else depending on the compiler. So for that, for overcoming that, we use a malloc size of int into 4. So if the size is 2 is placed here, and if the size is 4 will be replaced here. So there will be no problem for 2 to 4. This is how we will use malloc. And now malloc returns the starting address of this 8 bytes, and this will be stored in this word pointer. As this is an integer array, we must access integer by integer, but this is a word pointer. For this, we have to typecast this. Int star p equal to malloc returns word pointer, and we are typecasting it to int pointer. Malloc size of int into 4. Now we are ready to access each integer in this 8 bytes, integer by integer, using this variable pointer p. Using this integer pointer p, we can access every integer here. Okay, see here I had declared an integer pointer, and I had allocated memory for 4 integers, size of int into 4 integers, and for accessing integer by integer I had typecasted it. Now how to access this array of 4 integers? For accessing the 4 integers in this array, we use p plus 0 equal to value, and for accessing the first integer we can use p plus 1 is equal to value. Similarly for third and fourth, and we can also use in a different fashion p of 0 equal to value, which is equal to the above declaration 1, 2 and 3. Like this we are going to assign values to the integer array. P of 0 equal to value, for this it will go to the location 1003 and then allot this value for this location, and similarly for p of 1, p of 2 and p of 3. Let's have a brief summary about malloc. So malloc is used for allocating memory, and the syntax of malloc is void star malloc size underscore t of size in bytes. Size underscore t forcefully converts the given size. Even it is negative, it forcefully converts it into positive, which acts like an unsigned value. And malloc, after allocating memory, it returns the starting address of the allocated memory. And for accessing the allocated memory integer by integer, we typecast into int star, and for accessing char by char, we will typecast it to char star. Similarly, for any other structures like structures, node star, etc., anything, we will just typecast the return value of malloc, which is void, and size of int into number of integers we want. Similarly for char, how many characters we want, char. Similarly for all of the things, for struct node, which you want to define your own structures for that. And there are few special cases in malloc. Malloc returns null or -1 when the allocation fails. I will show you. See here, I have allocated 5 bytes of memory, and the return address is in p. The starting address of the 5 bytes is in p. If P is null, the allocation is failed, else the memory is allocated. Let's see the output. See here, the memory is allocated, and if I change the value to negative value, if I change it to -5, then let's see what happens. See, the allocation is failed. And I will show you another special case where malloc fails. If there is no continuous memory to allocate, if I ask for max int of memory for allocation and it is not available in our memory, then also malloc returns null. Max underscore int, sorry, limits.h. It was int underscore max. See here, observe this, memory allocation failed because we don't have int max number of bytes available for allocating for this memory. Until now we have discussed about malloc, and now we can see another memory allocation functions. Calloc. Calloc is also used for allocating memory. Coming to the syntax, except this one argument, everything is same as malloc. The return type, the size in bytes, and everything is same. Now we have to talk about this argument num. Here we can specify the count of number of items of this size we want. We want 4 integers here. For that we will give calloc 4 comma size of int. We can see an example. Okay. Int star p is equal to int star calloc. I need 4 integers and size of each integer is size of int, which is equal to int star malloc size of int into 4. Here we can directly specify number of data items we want of this size. We need size of integer and we need 4 data items of size of int. Thus we have declared like this. Now it will check whether there is space for allocating for 4 integers. 1, 2, 3 and 4. It is available. So it will allocate 4 integers of memory for this program, and the starting address of this allocated memory will be returned to P. Now P contains 1003. Then what makes the difference of malloc from calloc? What is the difference? First of all, we can talk what C in calloc mean. C in calloc has 2 meanings. C means count and few others say P means clear. Actually both are correct. Why? To understand what C means, count means, we know here we can specify the count, mean how many data items of this size we want. Here we are specifying the count here. Thus it is called count alloc, calloc. And then what about the clear here? What does the clear mean? This is the major thing that makes the calloc different from malloc. If I say int star p equal to calloc 4 comma size of int, then it searches for 4 free integer sizes, that is 4 into size of int, and if there are available memory, then it returns the starting address by clearing the garbage in that. Mean it will clear this garbage, all this garbage, and it will initialize the values to 0 and then returns the starting address to P. This is the major difference between calloc and malloc. Malloc only allocates the memory, but calloc, allocating the memory, it will clear the inputs which is clear and then initialize the value in that. Now let's see an example of malloc and calloc. Int star p equal to int star malloc size of int into 4, int star r equal to int star, I will use calloc size comma size of one data item int. Now we'll print the values int I equal to 0, I less than 4, I plus printf percentage g percentage t and p of I comma r of I. Let's see the output. See here, the values that are allocated using malloc contains garbage values, and then see what we had allocated using calloc. They are initialized to 0, 0, 0 and 0. This is the major difference between malloc and calloc. Now let us talk about another allocating function, realloc. Its name itself suggests that reallocation, which means the memory allocated using malloc or calloc is going to be reallocated by realloc. Here in syntax, except this pointer, everything is same as malloc and calloc. Then here we must talk about this pointer. This is the pointer to the memory location which is allocated by using malloc or calloc. Where realloc is used, let's have an example here. If an array is declared using malloc size of int into 3 or using calloc 3 comma size of int, then the starting address of this 3 bytes is stored in P. And now there is a situation that we don't need 3 bytes, we need only 2 bytes. And in this situation, realloc is going to be really useful. We want to reduce the size of the allocated memory, then we must choose realloc. Int star p equal to int star realloc. The memory allotted by calloc or malloc, the starting address is P, is contained in P. Size of int into 2. You want to decrease the memory, then size of int into 2. Now here we have allocated 3, but you want only 2 bytes. you have allocated 3 but you want only 2 bytes, then you use realloc size of int into 2. Then what happens means here in this 3 bytes 1 byte becomes free, then only 2 bytes is available. But if you have a situation that to increase the size, then use int star p equal to int star realloc p comma size of int into 5. You are increasing the memory, you are reallocating the memory to 5. Then what happens means here you don't have 5 bytes continuously, so the system searches for 5 bytes continuously. 1 2 3 4 5, so it has 5 bytes continuously. Then what it does is it copies 1 byte after 1 byte from here, allocates memory here, and then returns the starting address of this to here. This is how the realloc works, and there are few conditions that realloc must be used only for dynamic memory, not for static. I mean, if you consider an array of size 4 and you are using a realloc for that, realloc a comma size of int into 10, this may behave in another way. I mean, it is not defined, it may behave differently. So it is always recommended to use realloc on only dynamically allocated memory, that is using malloc or else calloc. Until now we have learned how to allocate memory using malloc, calloc and reallocate memory using realloc. And now we can see how to free this memory which is allocated by malloc, calloc or realloc. For that we have a function called free in C. Let's see the syntax. It returns nothing, thus the return type is void, and it takes an pointer argument. This pointer points to the memory which is allocated using malloc, calloc or realloc. Let's see. If P contains the starting address of this 5 bytes which is allocated for the program using malloc. Now these 5 bytes are reserved for our program, making these 5 bytes unreserved for our program so that some other programs use these bytes is the main aspect of using the free function. Free P. After calling this function, this will go to this location and here it will start freeing the memory. Now this memory can be used for some other program. This was not reserved for this program. That was the main aspect of using free. Now let us see a final example how to allocate memory using malloc for a matrix of 5 into 5. For that we initially create a pointer star p of 5 rows and then for int I equal to 0, I less than 5 plus plus. What we do is we have defined 5 pointers, and in each pointer we will make each pointer to point an array of 5 integers. So p of I is equal to int star malloc size of int into 5. So what does this do? The first statement star 5 mean it will create an array of 5 pointers. Here it creates an array of 5 pointers. 1, 2, 3, 4 and 5. Now this statement means it creates an pointer array of size 5, and now in each pointer we are assigning the starting address of a 5 byte 5 integers. Now this points to the starting address here, and this points to the starting address here, and this and this points to this, and this points to this. This is how we will declare an 5 into 5 integer array. And how to access this? For accessing this, we can directly access like an normal array of j equal to 5. Let us take an example. Value p of 1 of 3 is equal to 10. What does this do? Here p of 1, initially it will go to p of 1. P of 1 means star p plus 1. So initially it will go to this. This is p and this is p plus 1 here. So it will go here, and now in this array the third position 0, 1, 2, and this is the position which we want. So like this we will allocate memory for a two-dimensional array. There is another approach using only single pointer, that is a single double pointer. I'll show you that. Int star p is equal to, it looks a bit complex but it is very easy if you understand it. malloc size of int star into 5. Understand this line. So earlier we had declared int star p of 5, right? These both statements are really equal. See, what does this mean? It declares it's a double star, it's a small pointer which is p, and this points to an array of size 5, an array of size 5, and it contains int star, it contains integer pointers into size 5. So size 5 integer pointers, so 1, 2, 3, 4 and 5, each are integer pointers which is equal to this is equivalent to this. And similarly after this you can write the same code, initializing for int I equal to 0, I less than 5, I plus plus, p of I equal to int star malloc size of int into 5. Each integer pointer points to an array. This is an integer pointer of size of int, and its size is 5 into size of int. And now p of I contains the starting address of 5 integers. So now p of I points to this location, and p of 1, 2, 3 and 4. Like this, we can use a pointer directly, or else you can use a double star pointer like this. Thank you for watching.